Hi and welcome to WB and video maths here. This is your daily dose of integration. Today we are going to solve two questions. One is this, the other one is this. This one is like algebra, cancel x power 6 x cubed, blah blah. And the other one is trigonometry. Interesting. And the first one is actually from Putnam and Beyond. It's a book which people refer before taking the Putnam exam. Putnam exam is like the hardest math exam in America. And I'll give a little background on that one. And this question has nothing to do with it. It's fairly easy compared to the questions that's actually asked in the exam. And I don't think quiz as a whole is part of Putnam exam, but still. So there's like 12 questions, and each question like weigh 10 points, 10 marks, you can say. So the total is around 120. 120 is the maximum score. Where do you think the average is gonna lie? At verse 20, two questions. People can solve two questions. No, it lies within one, 0 to 1. That means a lot of people score zero, literally zero. And these are not people that, like some high schoolers go take the exam that doesn't know math. The people that are actually taking the exam are people that do mathematics as a course in college or something. Their field is mathematics. That's the standard of the exam. That's pretty hard to do some videos on different paper in some time. This will be interesting, of course. And I also don't know how many I can solve myself. I don't know if I can try. I don't know if I can do it actually. I mean, this stats are pretty scary. Anyway, we'll do what we have at hand right now. This is a question, and yes, you can pause the video and try it yourselves, and check if you're right. With that, let's see the question. The first one is okay, x power 6 plus x power 3 plus 2 dx. So if you have been doing integrals for a while, you could say like we can do a substitution right away here and expect a good result because we aren't going to get one. I mean, substitute this to some t or x. I mean, whatever you do, I mean, there might be some good substitutions, but straight away, I don't think so. There's no like specified method to do here. You can always do integration by parts, and good luck with that. Please let me know in the comments how that goes. But what I think we can do is kind of tricky. This is like straightforward, but still tricky. X power 5 plus plus x squared. I'm taking x out, okay? Multiplied with the same thing, x cubed plus 2 dx. Now what I'm going to do is take the x inside cube root. So we're going to have x power 5 plus x squared multiplied by x to the power 3 multiplied by x to the power 3 plus 2 dx. Now that's going to equal x power 5 plus x squared cube the root of x power 6 plus 2x power 3 dx. Yeah, or can we do something here? You're damn right, we can do something here. I'm going to say t is equals to x power 6 plus 2x cubed. So dt is going to be 6 times of x power 5 plus 6 times of x squared. So I think that's 6 times of x power 5 plus x power 2 dx equals dx. This is my dt. And that's exactly what we have here. Cube root of t dt by 6. dt by 6. And that's going to be 1 by 6 integration of t to the power 1 by 3 dt. It's nothing but 1 by 6 times of power 1 by 3 plus 1 is 4 by 3, 5, 4 by 3. It to be uh, 3 by 4 into 1 by 6 into t power 4 by 3 plus some c. We never miss the c. 1 by 8 t power t can be written as, let's just substitute by x power 6 plus 2x power 3 um, to the power 4 by 3 plus c. That's pretty much it. So that's one question. Integration of cos x minus sin x by cos x plus sin x dx. Okay, what can I do here? I mean, sine and cos, you see, we can do substitutions because integration of sine is cos is sine, something like that, with a minus, of course, sometimes. And yeah, that's good, but dealing with sines, I mean, squares of trigonometry is always a good practice. We have many formulas, many equations that might help us solve. So what I'm going to do is multiply and divide this whole term with cos x minus sin x. So what's that going to give me? Cos x minus sin x by cos x plus sin x multiplied with cos x minus sin x divided by cos x minus sin x. And why am I doing this? Because dealing with squares is fairly easier than what I had before. Also, if I multiply this, what would I have? Let's see. Top one is going to be cos x minus sin x whole square divided by cos square x minus sin square x and dx. This is what I have. Now, cos square x plus sin square x. If you know trigonometry, you should be aware of this formula. Cos 2x equals this. So now I can write, I'll expand this term, cos square x plus sin square x minus 2 cos x sin x, just a minus b whole square, by cos 2x and dx. We know cos square x plus sin square x is 1 minus 2. Now we have another thing, right? Sin 2x is equals to 2 sin x cos x. And I'm going to replace 2 cos x sin x with that. Sin 2x by cos 2x dx, which is going to be 1 by cos 2x, which is secant 2x dx minus integration of tan 2x dx. Now, I think I've proved these two some point in the series, so I'll just link those in the description as well as you can see it on the right corner. You can click them and see the proof. So I'm just gonna do this straight away. This is ln of secant 2x plus tan 2x 1 by 2 minus ln of secant 2x plus c. That's the answer. You're welcome. Or if you want to go one step further, half ln of secant 2x plus tan 2x by secant 2x. Just a property of logarithm. It's going to be, let's go one step again further, 1 plus sine 2x. Yeah, that looks pretty neat to me. This was the integral of cos x minus sin x divided by cos x plus sin x dx. So that's the two questions of today, and sooner will be. These were fairly easy, and the first question was kind of tricky, and the second question is easy if you know trigonometry and integrations of trigonometric functions. I actually have a hard question, which I'll discuss in the next video. Thank you for watching. I hope you enjoyed it. See you in the next one.